Okay. Welcome to the April edition of Tech Lancaster. I'm going to be hosting Tech Lancaster tonight. My name is Tom Swartz, for those of you who don't know me. Before we get into it, I have a couple announcements. First off, the Tech Lancaster meetup for May will be Brad Spangler, and he'll be presenting 10 years of Linux security, a report card. I believe that will also be streamed as well, and the details for that stream will be posted prior to the event in May. Further, the Lancaster AI meetup is scheduled for a remote meetup, and it will occur on April 28th at an earlier time than usual, at 6 p.m. this time. And the organizers request that you check the Slack channel for the Lancaster AI meetup to get the stream URL for that. As you can see, we're also kind of experimenting with the layout for tonight. We have the YouTube chat down below, and then in the bottom corner we also have the Tech Lancaster Amish Tech Lancaster Slack channel posted as well. So if you have any questions along the way, if you're interested, pop any questions in, and I'll try to get to them as quickly as possible. It seems like the stream is about a minute or so behind real time, so if I don't see your question right away, I'll try to answer it as soon as possible. So shout outs to everybody that's already in. The final thing I want to talk about, it's a really important caveat for today's session. I'm not a doctor, obviously. I'm not qualified in any way to kind of provide any sort of medical interpretation of coronavirus information. If you're concerned about coronavirus, or if you have any questions or anything like that, you should definitely consult a doctor or someone who's qualified. I'm not. I'm just some dude with a calculator that's kind of running through some numbers and talking about things tonight. So, just kind of a blanket statement here. All of the information that we're being, talking about tonight is just amateur interpretation of publicly available numbers. And if you're interested in the real statistics and the real information, definitely seek out those who are qualified to speak about it, much more than I am. So, without any further ado, let's just jump into it here and kind of get started. So, to kind of set the scene, if you've been living under a rock, or if you're not familiar with coronavirus at all, or maybe you're watching this in the future and you totally forgot about the whole year of 2020. I know a lot of people who might like to. Coronavirus, COVID-19, is a highly infectious disease that's been spread worldwide, causing issues, causing a large number of deaths. And, as a result, there's a lot of interest and a lot of push behind trying to keep tabs on, how many cases there are, who's infected, where they are, and things like that. A lot of the resources are available nationwide, worldwide, but there's not really a lot of focus specifically on local data, state-specific data. The organizations that do provide the data, like we'll see in a moment, they just kind of give raw numbers. They don't kind of give any historical data. They don't give any interpretation of that data. It's more or less just, here are the numbers, have fun. So because of that, being in quarantine and having the stay-at-home orders, not really having anything to do, I thought it would be fun to try to hack up a script that would kind of take all this information and allow me to visualize it in some sort of way. It's a little bit, more interesting. So as you can see here, we have the Pennsylvania Department of Health website, and this page is kind of the centerpiece for all of the stuff that we're going to be looking at today. This page updates daily, usually around noontime, and part of the problem, which kind of spurred this project, was right at noontime when they do update, it seems like there's a lot of hiccups and issues and kind of a lot of problems trying to get that information in a timely fashion for multiple reasons. Since this is for the entire state, a lot of people in Pennsylvania who know about this are actively refreshing at the time, trying to hit the page and get the most up-to-date information. And at the same time, from the Department of Health side, they don't really have a lot of resources and things like that to make sure that the pages are very robust. Perhaps they're just trying to get the information in and post it as quickly as possible. So very frequently there's a lot of timeouts and a lot of issues right around noon. Sometimes you might not get the information until 1:30, 2 o'clock in the afternoon until they get everything sorted out. So for all that they're doing a great job. I highly commend the Department of Health for their action and what they're trying to do to handle this really terrible situation. But they obviously don't have someone on staff who's like a full-time web developer. Just kind of scrolling through the page here. Let's look at the source code. It's obvious that this page is just kind of machine parsed. Perhaps that they built something out on SharePoint and had kind of machine code spit it out and render the page. Obviously they don't have an API that you could query and kind of get all the information that you would like that way, so on and so forth. So we're kind of relegated to having more or less a brute force approach to getting this information off this page and viewing it in a reasonable fashion, kind of doing our mathematics to it to figure out what's going on. So all of the information that we're going to be talking about today is hosted in my repository here, and I'm going to share this in the chat. Give me one moment here. So the root of everything that we're going to be working from today is a Python script that I wrote up. And let's take a peek at that and kind of see what it does. We'll talk through kind of how this script works, and then we'll see it in action, and then we'll go through the actual act of processing today's data. So as you can see, it's a pretty simple Python script. We're using a couple modules, Beautiful Soup, which is a module that helps us parse HTML, Requests, which is a module that allows us to kind of actually get the content of a web page, and a couple other modules that allow us to manipulate and handle the data in a reasonable fashion. I do want to point out here the script. I wouldn't say it's enterprise grade. I wouldn't say it's anything kind of none of the things that we're doing here are kind of enterprise grade. This page for the coronavirus information, they change the format daily. They add things, they remove things. So it doesn't make very much sense to go through and kind of build out a really robust script that would handle each edge case and exception and stuff like that, because quite frankly it's just going to break the next day. So because of that, I kind of had to go through and make make some exceptions and design it in such a way that it would handle that expected breakage in the way that the data is presented in the page. Some helper functions are here at the top of the script, but really kind of the meat of it is here. So we have Beautiful Soup, which is parsing the raw HTML, and the script really does three things once it gets the raw HTML. Actually, let me take a side note here. The only thing we're pulling here is the HTML. Like I said before, around noontime or so, the script tends to, or the web page tends to, get really heavy traffic. So there's a lot of people that are hitting the page, loading things up. Perhaps they don't have this humongous image cached or any of these logos cached, any of the fonts or anything that they're using on the page. This script kind of bypasses all that. It just gets the HTML and only the HTML, so it kind of lessens the load on the page. So that's kind of a design choice on my part to kind of work around this. Anyway, so back to what we were talking about here. So the script does three things. It will query the page for the updated time. Obviously, we want to know when the page was last updated. See if it was updated for the day, for the most current day. If they had updated it, after the fact, sometimes they'll go back and revise data, 2 o'clock, 3 o'clock, 4 o'clock in the afternoon. So, it's useful to have that printout of when that page was updated so that you can see when the numbers are, kind of related to. So that's the first thing. The second thing it does is it sorts through and it looks for each table row. Like I said before, they obviously don't have a full-time web developer on hand. None of these tables have any kind of, WC3 standards compliance to them. They're not really built out in any kind of proper way. So we just kind of skirt around the way that they're handling all this data, and we just look for each row, and we take each row and each item in that row and kind of make a big list of lists to it, and then that gets put into a JSON format, as you can see here. From there, we take all of that information that's not quite accurate. Let's go back here and look at the page. Percentages that they use aren't always accurate. They aren't always 100%. Some of the stuff they only had recently started posting within the past couple days, so we don't have historical data. So quite frankly, all we're interested in are the raw numbers, and we could take those raw numbers and make our own assumptions from them. We could make our own rounding issues and things from there, and that way we're 100% certain with the actual data that we're working with. So that's what the script does here. That's the second thing that the script does, is it'll go through and kind of drop out any of that information that's not really useful or pertinent for what we're looking for. And then finally, the third thing it'll do is it will go through and print out in the console a very nice, pretty format of county by county statistics for each county's number of cases and number of deaths. And then, because it's my script and I can do what I want, I'm interested in two counties in particular. Lancaster County, because that's where I live now, and Schuylkill County, because that's where I grew up. So I have some extra logic in this script here, so that it'll highlight those counties in particular, so that I can see them much more easily in the list of information. So let's just look and see what that script looks like. Hop over here. And as you can see, whoops. As you can see, it's very easy to view all in one page. If I were to flip back here to the cases page, here are the county by county cases. Let me count here. 1, 2, 3, 4, 5. 5 scrolls of the scroll wheel to reach to the bottom of the list. So it's not very easy to parse, just very quickly and easily here. Let me bust this up a little bit so you can see we have our specific county callouts and things like that. So it's really useful, really interesting way of handling that data. So that's all well and good. That'll get the information on a day-to-day basis. That'll allow you to kind of see what's happening each day. And so what can we do with that data? So like any amateur statistician, I bust out a spreadsheet and kind of punch things in. So let's talk about the different items here, and kind of do a quick review of the information that you could kind of glean from that day-to-day data. These three columns here, date, confirmed, and deaths, are all the information that we're provided and all the information we're interested in from the Department of Health. So I'm just going to make this a little bigger here. The items here highlighted in gray are all of the things that we're calculating and we're able to calculate. The percentage of new cases, or the number of new cases, it's a very simple calculation. It's literally take today's total count and subtract yesterday's total count, and that'll give you the number of new cases. The growth ratio is a really kind of the root of all of the calculations that we're going to be looking at. This is sometimes called the R0 or the RN number, sometimes called the infectivity rate. More or less, it's basically just how many people are infected by those who are how many people are newly infected by people who are currently infected. The actual calculation for this value, the R0 value, is incredibly complex. In the repository, I have in my GitHub repository, I have a link to the to a page that'll actually provide like a full function that will calculate R0, but a very simplistic approximation for this value is literally just the ratio of total cases from one day to the next. So it would be today's value minus yesterday, or divided by yesterday's value, and that'll give you a good enough approximation for the growth ratio. Using this growth ratio, we can kind of estimate how many cases there will be for the following day. So that's taking our growth ratio and multiplying it by the number of confirmed cases, and then that'll give us a guess for the next day. And then the last two columns here are kind of error calculations for that estimation. That'll tell us how much we are off by, and then we calculate the percent error from the estimation to the actual count. So that kind of gives us a pretty accurate view, and let's actually take this information and see how it matches up for today. The calculated value, the estimated value, I should say, for today was 34,208 cases, and the actual value was 34,528. Running those numbers here, that gives us a 0.93% error. So even though I said it was a very rough approximation for the growth ratio, it gets us probably within 1 or 2% daily. These numbers that were really high here at the beginning were just because we were working with such small numbers, and the variation from day to day was pretty great. But as time goes on and things kind of follow their trend, we see here that just taking that ratio of one case from one day to the next gets us within a good enough guess to kind of see where we're going. So we have all that information. We have all these little kind of tidbits of information. So how can we graph that out and kind of do that in a repeatable fashion? Spreadsheets kind of give you the ability to make these graphs within the spreadsheet. They're all well and good, but you can't really kind of take these graphs and put them someplace outside of the spreadsheet very easily. Sure, you could probably copy and paste it or take a screenshot or hold your cell phone up and pretend you're a boomer and take a picture of the screen, but that's not really a repeatable process. So what we can do is we could take this data and we could feed it into a program called NewPlot. NewPlot is a very, very incredibly powerful program for creating plots and visualizations of data. Anybody who's kind of worked in the sciences is probably familiar with this. If you've worked on LaTeX documents or anything like that, I'm sure you're probably pretty familiar. So we'll take our data and we'll punch it in and see what NewPlot can do. So let's just do that. I'm going to copy our data from the spreadsheet here, and I'll flip over to the terminal and make the terminal size bigger. Cases.data. And the data that NewPlot expects is pretty flexible. You could kind of include whatever you want, however you want. And then you could tell NewPlot how to plot that data out very, very quickly and easily. So let me save that. And what we'll do is we'll look at the NewPlot script that I have, and then we'll go through and we'll actually create a plot ourselves to see how simple that is. First things first, let's look at the plot script. So hopping up to the top here, this script will do a couple things. So it creates two separate image files, and the first image contains 3 plots of data, and the second image contains 2 plots of data. Each of those images, when they have multiple plots contained in them, they're called a multi-plot. So let's kind of just step through the script and talk about it here. What we're doing is we're setting the x-axis value as the time, and we're telling the format of that time. We're going to give the y-axis a label, and we're going to set some options for scaling and showing a grid on the screen. And then we set the size of the image file that we're interested in, the file name for that image file. These are some comments here for kind of some side experiments that I was working on. And really, here's the meat of it. This single command saying plot our cases.data using, and I'll show you here, cases.data. So the kind of incantation here is we're going to use column 1 and column 2. So column 1 is date and column 2 is number of confirmed. And we're going to display that using lines and points. And we're going to use line style of 1, and we're going to give that a title of cases. And then the second graph here, the only difference, you can see that the plot is called exactly the same way, but the only difference here is we're setting a log scale for y. So let me flip back here to our repository, and I'll show you the script, or show you the images that were generated by the script. And here you can see that data plotted out. And it's the same data. The only difference is for the second one, it's following a log scale. Pretty amazing and powerful. So what's really neat about this is if anybody's used Git, worked with Git, at all, you're probably pretty familiar with the fact that Git is notoriously sensitive to changes in files. What's really unique about the way that NewPlot generates these images it is 100% repeatable every time. So you could go through, and I'll even show you here. We have our git status. We have our information here, GNU plot. We're going to generate our images, and I'm going to commit 21 April 2020 data. Always sign your commits, folks. So all that information is now up on the repository. And if I run this script again to generate the plots, there's no difference. So the image files, even though they were up to date, and I'll kind of further drive the point home here. Cases.png. I'm going to remove the file, and I'm going to rerun it. And as far as it's concerned, the file is exactly the same. So it's a super robust, super powerful way for generating these plots and interpretations of the data. Talking through the other graphs that I have here, obviously these are the cases, these are the fatalities. Here's a plot of the growth ratio, the R0, the infectivity rate, and you can see it's trending downwards. Actually, let me refresh and make sure we have the most recent up to date. So you can see it's trending downwards. And then I have what's called a trajectory graph. This is based off of some visualizations that the wonderful folks over at Minute Physics, the YouTube channel, were able to kind of come up with. The idea here is this trajectory graph will show a steep drop off very early in the event that the cases start to slow. So it makes it very obvious when the cases are starting to slow down. The number of new cases are starting to slow down. That means we've kind of hit the top of the curve, or more or less, or kind of over the hump, so to speak. So that's NuPlot. NuPlot's very simple, very powerful, very robust, and very easy to use to kind of create repeatable graphs for your information. But those graphs are pretty static. There's no real interactive way to view that. Whatever's provided there is obviously just a static image. How could we take that information and maybe add an interactive element to that? Is that possible? Actually, it is. So we'll take that data and we could load it into a database and use Grafana to interact with this data. So let's step through the process of loading it into a database and kind of seeing how Grafana displays and interacts with this information. So I'm going to slip back here to the terminal. And what I'm going to do is I'm going to take the information that we have from our spreadsheet and the information that we provided to the NuPlot data, and I'm going to more or less just convert it to a CSV file. So I'm going to take the last line here and I'm going to add it. And make sure our percentages are not there. And close this. What I'm going to do is I'm going to convert it over to actual CSV value. And now I'm going to use pSQL. I have a database set up, and I'm going to use pSQL to kind of copy that data in. So I'm going to connect to my database here, and I'm just going to copy that CSV file in. And it copied those 2 lines in from yesterday and today. And let's hop into the database really quickly and look at it. So as you can see, the information here is more or less exactly the same as the information that we have in our cases.data file, or in the spreadsheet file that we were using. It's all the same to the database. So let's flip over here to Grafana, where I've kind of gone through and set up a dashboard already. We're just going to get rid of the chat windows for a moment. And if we refresh, we'll be able to see the most recent data appear. And what's really useful about Grafana is that it allows you to kind of drill down and interactively view the data that you're interested in. So, if you want to look at, just the last week, it'll give you the data that way. Let's look at the last 30 days. Another really interesting aspect that Grafana has is it has these annotations. These are little bits of information that it'll overlay on top of the graph that allows you to correlate events or things that happen. More often than not, when this is used in a large enterprise environment, maybe they'll have, if they're tracking, certain statistics, they'll have an application that'll write into a database that looks at these annotations, so that they could say, oh, we did this at this time, and you could see the action spike and the reaction spike from there. But in our case, we're using it to track major events in the Pennsylvania response to coronavirus. And it makes it very easy for us to kind of use those annotations and look forward or look backward to see how they kind of affected things. So, for example, around the 1st of April, there was a statewide stay-at-home order that was announced. And let me flip over here to the full large screen. As you can see here, there was a statewide stay-at-home order that was announced. So let's drill in, and we'll do the day before that, and we'll go to, let's do the day after that, day after 2 weeks. The reason I chose 2 weeks is, according to the best estimates for coronavirus infection, I'm just kind of going from the media and what's been kind of relayed here, is the infection tends to show within the first 4 to 14 days. Sometimes 2 days. There's a bit of a window there, kind of what I'm saying. So we have our statewide stay-at-home order, and 14 days later, 15 days later, we should expect to see some changes in the way that the infection is. So as a matter of fact, if we look down here at the growth ratio, we can see that it has been consistently dropping since that statewide stay-at-home order has been announced. So that's really cool, really helpful, and really interesting to kind of see how those things act and react. It also allows you to, like I said, you could kind of play around with the data, and you could see specific time windows and drill in a little bit more in depth than you would normally be able to see with, for example, a new plot without any extra configuration here. So you can see here perhaps, if I drill in a little bit closer, on the 12th, for example, we could see that the actual number of confirmed cases was significantly lower than the actual estimate, or from the estimate of the cases. That's perhaps due to, making absolute conjecture here. It's perhaps due to the decrease in infections due to the stay-at-home order, people using masks, and things like that. So, really interesting, really insightful way of kind of handling this data and looking at it that way. So I hope that this was a fairly useful insight into kind of how you could use open source tools such as Python, Nuplot, Grafana, Postgres, and so forth on how to kind of handle this data. Do we have any questions? Any kind of questions in the chat here? Anything that I kind of hand wove over that you'd be interested in seeing? I'll pause for a moment here, see if there are any questions coming in. So, hearing none, I'm going to assume that this was a very insightful session. If you have any questions, or if you would like to follow up afterwards, actually, it looks like we have some questions popping in. So it looks like Jason had asked if it was possible to use PostGIS to put the data on a map and view that growth visually. As a matter of fact, there are a number of folks that are actually doing that. I don't have the environment set up currently to kind of go through and visualize all that information with PostGIS, but I'd be more than happy to kind of play around with it and kind of show some demonstrations using that. Another question here from Jason, taking an image from each day and making a GIF out of it. Yeah, that's actually another possibility as well. Since I'm storing the images in Git on GitHub, I tend to not like to put images in Git, but I think for this example, for this use case, it's pretty clear cut that it's useful in this case. You could absolutely go through the Git commits for each day and kind of build up a GIF animation of how that graph changes over time. That would be something very interesting to kind of play around with once we're over the hill and kind of back to the new normal, when things tend to settle down here. Great. So thank you all for attending. I hope you all stay healthy and stay well, and have a great day. Thanks.